I'm Skip Laitner and my colleague Karen Ehrhardt-Martinez. We've been collaborating for a few years now and trying to, if you want to think about it, maybe how to bring prosperity together in the climate debate in a very material way. And to that extent, we want to explore, not unlike the discussion Dan presented with us this morning, energy and information, but more critically at a fundamental level, energy as we might see it at work in the economy and how it may constrain, and the energy that might lead to what Karen will talk about a bit more is the social engagement. So information leading to social engagement. And we're talking about in the context of human dimensions of the growing energy and climate imperatives. And there is indeed, I think we'll agree, an imperative. Now, Karen is a sociologist. I'm an economist. I got to thinking about Dan's earlier description about exploring the entire elephant. The economists are probably the ones that want to understand the urinary tract and really get a better sense of the theory of the trickle down. My only saving grace is that Karen sometimes will acknowledge that maybe I am more of a social or closet sociologist, and I hope that, in fact, we'll see that expand just a little bit in time. But with that said, yeah, the human dimensions and bringing together the energy, the information, but then more critically, the social engagement, a bit of time we had with you. And I want to talk opening with a comment by John Wheeler. He was a physicist, professor emeritus at Princeton, died a couple years ago. He was probably one of the few physicists who should have won the Nobel, never did, but he's a deep thinker. You probably know him as best the guy who coined the term black hole. He was one of those, he really thought some things through. And I came across his work in the 70s, that long ago, and he commented in answer to a question by some of the reporters, how the heck are they thinking of some of these ideas? And his comment was very simple. We shape the world by the questions we ask. What I'd like to do to open up this discussion is ask and explore some different questions, some opening observations, if you will. It turns out work that Karen and I did 2008 or so.
2009.
Well, the how big
that's
efficiency,
2008.
yeah. Energy efficiency is the farthest reaching, the least polluting, and the fastest growing success story of the last 40 years that we probably never understood or heard of. Efficiency, as it turns out, has met 75% of the new energy-related demands for goods and services since 1970, while new energy supplies, the oil wells, the pipelines, the transmission lines, the power plants, only 25%. And yet we always think of the physical proximity, the reality of that physical structure as the answer, as the solution, and it's been quite surprising. But with all of the efficiency gains, some of the work I've been doing with, you may know the name Bob Ayers, some consider him the godfather of industrial ecology. I've been working with him several years now. With all the gains, we are still an economy that is at best 13% energy efficient. Horrible. In other words, this huge inefficiency, this waste, if you will, 87% of all the energy we throw at the problem, the economic problem, appears in fact to be constraining our larger productivity and our social and economic well-being. Yes, Karen and I both agree, as Secretary Chu said in 2009, science and technology can create much better choices, but we won't get there unless we bring people back into the process, and that's the nexus, and hopefully we'll be able to succeed in that regard. So I want to talk through, to get the slide to advance there, yes, I'm going to go up here to some new work that has not been published yet. I'm going to give you first crack at it. Drawing on Bob's work, we are exploring what we call useful energy, not energy writ large, not raw energy, all the primary energy, but the energy as a physicist might think about it, the energy that's really necessary to move goods and services and create some sort of value by whichever means we choose to explore. What I've done is I've extended some of his work to look at useful energy per capita and useful energy per work hour. We've gone all the way back to 1900, and I'm sharing these values 1950 to 2010. And there's some interesting things at play. Already you can see there was a heck of an improvement. Useful energy being put to work, not wasted energy, but useful energy. And it's flattened out over the last 30 years, and that's a problem. It's a problem we don't realize because we haven't got the data that we're tracking unless you do the laborious work that, yes?
Can you explain useful?
Useful means the actual energy that's expended to generate, say, a dollar of value added. It might be if I'm lifting a book, I'm expending useful energy moving against gravity, if you will. If we apply that same concept to...
Energy, but are you measuring it against the metric of money?
No, as value, yes, in a sense, value. We take a look at the energy that's actually used to create light, for example, to create so many lumens, how much energy is actually doing that work, and then we...
That's efficiency, but you're using it against the GDP?
And then against GDP, yeah.
So it is money?
Yes, yes.
It's not necessarily work.
No, not, a lot of energy is used, but the actual work that gets done is the 13% efficiency. So we may throw 100 quads at the problem, but we're only using less than that, 13 quads, to actually accomplish, to actually consume or produce that dollar of value added, if you will. And what I'm going to do here is show you that metric as applied to physical resources per capita. And what we've seen is we've grown the index from 1950. And in this period of time, what we found is that energy efficiency, not as the EIA, the Energy Information Administration, might use it, but as we might look at it from an exergy purpose or a useful work compared to the raw energy thrown at the problem, about 1.5% a year. And our larger economy-wide productivity, about 2.25% a year. That's through the period 1950. But over the period 80 through 2010, the efficiency has actually declined to about 0.4%, 0.4% per year. And more critically, what we're looking at is the economy-wide productivity has declined to about 1.7% a year. Why is that important? 0.5% a year in productivity by the year 2030 may mean an economy that's $2 trillion smaller. That means we've got less money to invest, less in the way of revenues to help solve the problems we're creating today as a result of the way we now look at the energy and the economic problem. And that's a critical problem. So how to generate a new understanding is going to be a critical aspect of what we do to move ahead. So the point here is to regain and maintain a robust economy. The suggestion is we can no longer afford business as usual. Rather, we're going to have to scale to the level of what we call an energy revolution. There is a critical dynamic at play here. And as Karen actually came across this the first time with Clay Shirky, creating an energy revolution, a revolution doesn't happen when society adopts new tools. It happens when society adopts new behaviors. And there is the critical junction. Understanding what really is at work in the economy, how we're wasting 87% of the energy, but reducing that waste makes it possible to, in fact, put energy to useful work. So people into the problem, examining the scale of the behavior resource. What we did in 2009, Karen, I, and another colleague, is take a look at imagining the heft that might be behind behavior as an effect resource. People don't really resonate unless they get a sense of scale and opportunity. We took a look at residential energy use, both in the home and the use of personal vehicles. And in 2008, the data we had, 38% of the energy consumption in the US today was directly controlled by households, one way or another. The question is, what's the scale of potential savings when people-centered approaches might be integrated into the discussion? Not just a technology perspective, but bringing people more actively forward. We identified more than 100 different conservation and efficiency measures, all cost-effective, that could be taken in a short period of time, roughly a 5 to 8 year period. And we did, without going into a lot of details, a Monte Carlo probability distribution to see how that might unfold. And a 9 quad savings, we imagine, could be generated, 9 quads of energy. And that's about 9% of the US's total energy, just from this behavioral approach. And we'll describe that in a minute here. This is actually a nice categorization that Karen was responsible for. We're taking a look, on the one hand, frequency of action, infrequent and frequent, how often these things actually happen, and then taking a look at low cost and no cost, together with higher cost investments. We broke it out into 3 categories. So the infrequent actions that could be taken, obviously, we call it energy stock-taking behavior. If you were to think about installing CFLs, or if you were pulling your refrigerator away from the wall to give it a little bit more breathing space so it doesn't have to work so hard because the heat doesn't build up behind the walls. Or if we're talking about frequent habitual behaviors and lifestyles, how that might save energy. Or then a different kind of consumer behavior, actually investing because you have better knowledge, better motivation to take actions, new windows, new appliances, additional insulation, all those kinds of things. To jump to this total here, we're basically saying the low cost, no cost actions, the conservation, lifestyle kinds of things got us about 57% of the total savings. And then the investment decisions got us about 43% of the total savings. So it's an interesting mix. We typically think of the need for investing in technology, and yet behavior, pure behavior, conservation lifestyles, got us a bigger return than the behavior resulting from smarter or more motivated investments. So what we found is that about 9 quads of energy, about 22% of the household controlled energy could be at play by bringing people more actively back into that decision process and understanding what motivates them, how they resonate with the information, the timeliness, and their ability to actually take an action. So how much is 9 quads? It's about 9%, as I said, of total energy use, 600 gallons of gasoline per household. That's a big chunk if we instituted that kind of behavioral response. More critically, it's the equivalent of about 240 medium-sized coal-fired power plants, and it's roughly the amount either to Brazil or South Korea, the amount of energy they use, slightly less than the total consumption of the United Kingdom, France, and Germany. Now, the two big conclusions we have from this analysis: behavior has heft. Behavior does have a big opportunity should we choose to explore it. Even these conservative estimates indicate that a behavior-centered approach can result in a significant amount of savings beyond what we normally imagine. It's not just a nice niche strategy. It actually has a reality. But it would require a very large shift in focus, policy, and effort if we are to engage and fully develop what we call the behavioral resource. So with that as a backdrop, energy has a very material basis, a very important underpinning for a lot of the problems we face today. But with the imperative and the scale of an energy revolution necessary, it remains large, we have to begin on how to then cross over to social engagement and deliver that information in a way that motivates. So we're going to explore first by exploring mechanisms of doing that through what we call feedback. And I'll let Karen take from here. Just click on right there.
All right, thank you. Thank you, Skip. So I just want to clarify one point, is that one of the things that really sort of sparked this research and a lot of the work that Skip and I have done together is that, we were frustrated in part by the techno-economic model that we've heard about earlier today, and the fact that, there are two typical responses to the energy climate problem. One is, let's find new sources of energy, right? And the other one is, well, let's get people to change their consumption practices by implementing, giving them the right financial incentives so they adopt more efficient technologies. Okay, so we took a step back and we said, okay, well, that's a real possibility, but what happens, if instead of trying to give these technological fixes to people, like having utilities tell people that they need to go out and buy a new refrigerator or put more insulation in their attic, that we take an approach that instead really tries to engage people in the process of making those decisions for themselves and making decisions that are more appropriate to them, as opposed to trying to find programs that are appropriate and appeal to the quote-unquote average American, which of course we all know doesn't exist in reality, right? If we go for the average, we miss the majority. And so the idea here is, again, sort of looking at, there's a lot of research that shows that there's a huge gap between the efficiency potential and the reality in terms of how much efficiency we use. There's a huge gap between what people's attitudes are with regard to energy in particular. I'm not talking about climate here, but energy in particular. People are very favorable. As a matter of fact, a Gallup poll a few years ago showed that 78% of people said that they should be spending thousands of dollars to increase the energy efficiency of their homes. What's the reality? Not even close to that, right? It's less than 2%, probably less than 1%. So there's a huge gap both in terms of the potential and the reality energy savings, a gap between attitudes and behaviors. There's also research that indicates that, in fact, we as policymakers in general and researchers to some degree have a misconception that attitudes create behaviors. If you get people to think about things in the right way, that they'll actually engage in better behaviors. If you get people to be concerned about climate change, they're going to do things to reduce their impact. But there's a lot of evidence that the relationship, the causal relationship, is actually the reverse. That if you can get people engaged in a process, then their attitudes will change. And so what I want to talk about today quickly are two things. One is some research that we did on feedback and the effect of feedback on people's behaviors and their level of engagement. And then I want to talk more generically about a general framework, because I'm one of the co-founders of the Behavior, Energy, Climate Change Conference, and I've been involved with huge numbers of people who are trying to do this work on the ground, and it's really exciting to see these people involved in the efforts that they're doing. But there's such a huge amount of information out there, as I'm sure all of you are aware, to try and convey this information to people who aren't social scientists is incredibly overwhelming. And so Skip and I have worked together to create something of a framework to convey this information to people in a sort of easy to digest, or at least easier to digest format. So the first thing I want to talk about is this new ACEEE feedback study. This was published in June of this past year, 2010. Skip and I worked on this with Kat Donnelly, who's a PhD student at MIT, and a number of other contributors at ACEEE. This was a paper, or a report, it's a meta-review of 57 different feedback studies that was sponsored by the Overbrook Foundation and has actually received a huge amount of attention since then. I've been invited to speak to a number of public utility commissions who are looking at the issues associated with smart grid and feedback and how they might, in fact, be successful in engaging people. So the assessment itself looks at 61 different primary research studies of 57 different feedback initiatives. So you can do the math and figure out that some of these studies looked at the same initiatives. Importantly, these studies span a pretty significant time period, 34 years in all, and number of different continents, 9 different countries. Most of the studies that we looked at actually took place in the United States, but there's one of the interesting things that we found, and I won't go into this in detail, is that there is actually really clear distinctions in terms of the findings, depending on whether you're looking at what you sort of the response to feedback in the energy crisis era, or if you're looking at the response to feedback in the current era, the climate era. So this graph is basically a summary of what our findings were. And we looked across 5 different types of feedback, and we found across these 5 types of feedback energy savings at the household level of anywhere between 4 and 12% on average by the type of feedback. So let me explain that in a little bit more detail. First of all, we looked at 2 different types of feedback, indirect feedback and direct feedback. Indirect feedback being the kind of information that people get about their energy consumption practices after the fact. So if you get a report the next day or the next week, or a month after you consume that energy, that's an indirect type of feedback. Direct feedback being those lovely little displays that you can get in your house now that tell you pretty much in real time how much electricity or other types of energy you're using. So we looked across these 5 different types of feedback. The first one being enhanced billing. This is, just out of curiosity, how many of you are familiar with O-Power's work? Okay, good. A lot of people. So this is gaining a lot of attention because, in fact, they've been able to integrate a lot of social science research and be effective by providing people with something as simple as a monthly home energy report, right? A piece of paper through the mail has been sufficient to achieve savings, well, in O-Power's case, of anywhere between 2.5% and 4%. But when we looked at these across the board, across all the different kinds of programs that have been put in place in both Europe and the United States, we found average program savings of nearly 4%. Estimated feedback is the kind of feedback that you get after you provide information about the size of your house, the age of your house, the kinds of things that you have in your house in terms of appliances and electronics and whatnot. And then, nowadays you put this all on a website and it spits back an estimation in terms of the amount of energy you're using. That kind of approach has resulted in average savings of nearly 7%. Daily, weekly feedback. This is typically the web-based information that a lot of utilities are beginning to pilot now, which is the kind of information that is usually about a day old. Where they use your actual energy consumption data that they're collecting either through smart meters or in some cases traditional meters. That kind of feedback has resulted in savings of about 8.5%. not surprisingly, the direct kinds of feedback have resulted in even more dramatic savings. 9.2% for real-time feedback at the household level, and 12% savings for real-time feedback when it's actually broken out in terms of your major appliances and how those appliances and how much energy they're consuming. The interesting thing here, or one of the interesting things here, is that so the numbers that we're presenting here in terms of percent savings are looking at, first of all, historical programs that in many ways are very flawed in terms of their design and execution. And they're also programs that haven't done a very good job of integrating a lot of the social science insights that we've been hearing about at this conference. And so this is strictly what's been done in the past in all of the sort of really basic ways that they've been implemented. If you look at specific programs, even, again, strictly speaking in terms of what's been done historically, some of the programs have achieved average program savings of over 20%. And so, again, you get a sense of sort of the range of what's possible. And so this last bar here is really meant to convey that sense of what's possible if, in fact, we were to design really effective and informed feedback programs that integrate not only a lot of these new feedback technologies, but also a lot of the social science that we've been hearing about today. So I want to shift gears here a little bit and talk about sort of some of the quote-unquote social science insights that are really creating a lot of buzz among participants, for example, at the Beck conference, and that people are trying to implement on the ground. And I talk about this in terms of a time model, or if you look at it in reverse order, you can call it the emit model. But in any case, what we're really focusing on here are 4 core elements. It's targeting, and by targeting, I mean being really specific in a variety of ways, being specific in terms of who we're talking to, again, sort of trying to move beyond this model of talking about the average American because such a person doesn't exist, but also targeting in terms of what's the right scale of a particular effort, what are the particular actions that we're asking people or trying to engage people in. Informing in its broadest sense, what kind of information do people need? What are the best ways of providing that information? Motivating, how do we get people to actually engage in these behaviors by using social science research about norms, networks, goals, and commitments, a lot of things that we've talked about already. And lastly, empowering. And empowering is really I would call it the sociological element of this, which is about creating opportunities and removing barriers, and the recognition that people aren't autonomous actors working in a vacuum, right? We have to recognize that there are existing social institutions and structures that play an important role in shaping what people do. So I'm not going to go into this in detail because we're already out of time, but I can give you examples about targeting programs that have been really effective. This is actually one of the, I think, real strengths of a lot of community-based social marketing programs, where they're strong advocates for going out and really understanding the people that they're trying to work with, the communities that they're working in, instead of making assumptions that, give people information, give them the economic incentive, and they'll do the right thing. We know that doesn't work. This is the alternative, right? The alternative is, let's really understand who it is that we're working with and create programs that distinguish between the opportunities and the constraints that different segments of the population are facing. And let's be really specific about what we're asking people to do. It's not enough to say, can you use less energy? People don't know what to do with that. And so a lot of these programs have found that, the more specific that you are in what you're asking people to do and making sure that that's an appropriate request for the people that you're talking to, that it makes a huge difference in terms of the actual savings that you're able to achieve. Informing, again, the feedback example, whether you're talking about residential energy consumption or commercial energy consumption, these kinds of feedback devices have been incredibly successful already without, in generating energy savings, and it's my contention that they could be even more successful. Motivating, this is an example from O-Power in terms of how they're using social norms to really motivate people to take action. And this is a copy of one of their home energy reports. Because if I ask you, how many people know how many kilowatt hours they used last month? Raise your hand. Okay, and this is an audience that cares, right? So the next thing I would ask you is, how much energy should you be consuming? And it's almost impossible to answer that question. But if I give you one of these home energy reports that tells you, well, you consumed 600 kilowatt hours last month, and your neighbor who lives in the same neighborhood with a house that's approximately the same age as yours and approximately the same square footage used 300 kilowatt hours that month, you're suddenly going to stop because you have a social context in which to evaluate that information and say, well, why am I using twice that much? What's wrong with what I'm doing? This doesn't make sense anymore. So that's one strategy for actually getting people to make sense of the information and do something with it. It's not enough to just provide the information. Okay, last slide is about empowering people. And there are a couple ways of doing that, but one of the ways that I'm sure a lot of you are familiar with is choice architecture. And this idea, I had to, when I read about this, I had to experiment. And so the Beck participants were my guinea pigs. So we had about 750 different participants in the Beck conference. And I said, let's do a little experiment. Most conferences, fortunately not here, typically provide a meat-based lunch. Let's instead of, when we send out the conference registration, instead of asking people if they have dietary restrictions and would prefer a vegetarian meal, let's just assume that omnivores also eat vegetables and not just meat. And let's just provide a low-carbon lunch, one that doesn't have meat in it. But we will also let people opt out of that scenario. If they really want meat, let them have meat. So we created this experiment, and in fact, maybe not surprising to anybody here, we went from the average ACEEE conference where 90 to 95% of people ate a meat-based meal to 20% in the 2009 Beck conference, which again, even if you think the proper frame of reference is the earlier Beck conference, where we had the traditional model, again, it's 20% versus 83%. So a huge change, and as most of you know, meat is responsible for a huge proportion of carbon emissions. So this has a lot of indirect implications in terms of climate change. And I'll let Skip close.
We couldn't come to some immediate conclusions except one. In a lot of ways, we're old dogs. And we're drawing on our American philosopher, Gary Larson. Here we've got a dog on a high wire act juggling a bunch of things. It looks like maybe a dead cat's included. The caption reads, "High above the hushed crowd, Rex tried to remain focused. Still, he couldn't shake one nagging thought. He was an old dog, and this was a new trick." And that's where we are. We need to develop some new tricks. And with that, happy to take questions or move on to the next. Thank you.